Hello, welcome back to my channel, and today we'll be looking at the latest updates that I've made to the FM synthesizer, and yeah, just a quick update, hopefully keep it a bit briefer than last episode's like mammoth session. So the first thing is, last time we looked at vibrato, and we had our presets, and so basically I've reworked this interface because, as you can see, the 20 cent position is here when you're just using the quick presets, and the 80 cent position is there. So when you had previously, before when you had the free choice button ticked, you didn't have really much like physical movement between 20 and 80, so it's quite hard to set a precise value. So what we've implemented now is when you tick free choice, you get this extra slider that controls so the small slider controls what the range is of the bigger one, so slightly confusing to describe, but hopefully quite intuitive when you use it. So at the moment it's in 0 to 50 cents. So it goes up to 50, down to 0. And yeah, you can go bigger, smaller. And you can even go right up to maximum of 700 cents, which probably sounds a bit mad. Except it doesn't sound like anything because we haven't got the low frequency oscillator turned on. We need to set a frequency, so that's something quite slowish. Now you can hear it's quite mental, because it's plus or minus 4.69 semitones. And if we put it up to 700, it'll be even more crazy. But yeah, I mean, it's there as a creative option, and it was something supported on the old Yamaha synths that I'm basing my design off of. So we didn't want the possibility that there might be something that you could do on the old systems that you can't do on the new. So we wanted to support it all the way up to 700, and yeah, it's useful for like kind of more for soundscapes than kind of modeling acoustic instruments. But yeah, and it's also just a lot more usable when you're using the lower numbers, like I say. And then moving on, let's turn vibrato off. So now we have a user interface for tremolo. I put tremolo / wah here because so what this effect is doing is it's in fact, let's go to the diagram that I made for this. Here we are. So what it's doing is we have our wave moving up and down here, and we have our LFO, which has a much lower frequency indicated by this dotted blue line. And if I increase the depth of the effect, I need to turn on, sorry, let's turn on the output, which is the orange line. So at the moment, the depth is 0. Obviously, the output is just the same as the input. But if I start turning it up, so what you can see is when the purple line's at its maximum, when the input's at its maximum, and the LFO's at its maximum, then we still get the maximum amount. But when the LFO's at its minimum, it's like faded down in amplitude. So that's what tremolo is when it's applied to a carrier, which we talked a little bit about carriers and modulators last time. Oops. Why is this picking up data? Sorry about this. we've got our little diagrams here of what are called the algorithms. So the carriers are the ones whose signal we can actually hear, and the modulators are the ones that are the oscillators that just they control the carriers, but you don't actually hear the modulators directly. Yeah, so they're moving the frequency up and down. So if we apply this effect to a carrier, then it's going to turn the volume up and down. If we apply it to a modulator, then it's going to automatically turn the amount of modulation up and down, which in an FM synth it sounds a pretty similar effect to opening a filter, so a wah effect. And when we have the final version, or a later version at any rate, we will be able to switch on the effect for individual operators, but at the moment it's just turned on for all operators. So it's tremolo and wah. So anyway, let's turn it on. And we've got our usual presets. There wasn't very many on the Sega Genesis. It's quite hard to hear. It's quite subtle. Let's work up the frequency. There you go. It's more rapid tremolo. And more rapid wah. Yeah, you can definitely hear it. Wah, 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 wah. And we've got our free choice. And in this case, so this slider is partially implementing like new stuff post 80 synths, but it's also allowing you access to options that were available on the more higher end synths that weren't like Sega Genesis. So I should mention, by the way, so conventionally you would usually measure tremolo in like decibels, but I decided to measure it in percent because, like, why not? So I just think it's more intuitive to beginners, even though it might, raise moments of hesitation with professionals. But so when it's at like 100%, so 100% means that the wave gets squashed down, so that even when the input, the purple one, is at maximum, it's being squeezed all the way down to 0 volume. So I don't know, maybe it's just my mathy background. That makes a lot more sense to me than decibels, because like, so yeah, same principle. So now we're in the 0 to 25%, so we can move this all the way up, and we don't need it going that fast because that's great. And we can go to 100%. Oh, sorry, I don't know what I'm doing there. I turned the range up to 100%. I didn't actually turn the slider up, so there wasn't any change. That was still at 25%. And now you might notice, like, the range slider is still not at maximum. So what is beyond 100%? Well, we can go up to 199%. So what does that mean? We need to go back to our graph again. So here, if I turn this up to 2, so that'll be 200%. So what this is now doing is when our input is maximum, our purple one, and our LFO is at minimum, the orange one is now, well, at minimum, but you can see it's been flipped in polarity. Positive's gone to the negative and vice versa. So what this represents in terms of sound is this is classic ring modulation. So let's go ahead and work it up to 199. Except our frequency is still pretty low, so perhaps it's still doing the ring modulation, it's just not very noticeable. So we need a re-choice of LFO. Let's set this to about 55 hertz, maybe. That is definitely ring modulation. Yeah. So yeah. That is the lesson for today, children. That if you turn your tremolo up beyond 100%, 200% represents ring modulation. And as for the stuff in between, bigger than 100 and less than 200, basically sonically it just works. It's kind of graduations, like between amplitude modulation and ring modulation. But what you call that, I don't know. I think the manual for the Korg Op6 just refers to it as both in different contexts. It just says like AM/ring modulation or something. But anyway, so let's have a quick sound lot. Listen to what 150% sounds like. Yeah. So 99. 99 with a very rapid frequency, don't forget. So we've kind of, yeah, we've gone past the outside of the scope of tremolo already just by raising the frequency. And then, yeah, anyway, 99%. 150, well, 151. And then full on. So yeah, little bonus feature there, just because the math worked out. We got ring modulation, which, as I mentioned before, it's kind of a 4-op synth and kind of an 8-op synth. I think I'm going to call it 4+4. So it's 4 lots of frequency modulation and 4 lots of ring modulation. Yeah. But this kind of stuff is an extra bonus. As we discussed last time when I talked about what is frequency modulation, it's basically just very fast, very high depth vibrato. And you can kind of abuse the LFO, especially in like, because it's a software context. So like we don't have like the physical constraints of like reaction times of electronic circuits and things. Yeah, any oscillators like any other in like the programming framework. So an LFO can be turned into an audio rate oscillator just as easy enough. So you can kind of abuse it for like an extra fifth operator. Yeah. So I guess ultimately it's a 5+5. Anyway, that's probably enough of that. Well, no. One more thing. we're going to move on to this tab anyway, so I'm just going to disable MIDI here for a second because I'm going to switch to a different tab where I've got another instance of the same thing running, and it's just that I have a patch programmed into this one already. Yeah, and as you can see, this is using our tremolo effect, but very fast at 55 Hz. Yeah, it's just a case of patience really, and setting up the envelopes on the individual operators, which we talked about last time. And the ratios, yeah, it's 3:1 instead of got 1:1 on the other two. Yeah, and we talked about the modulation matrix, and yeah, the numbers that you put in here. So it's lowered to 90, which is a bit more constrained than 99, which is kind of, I think of it as being like overloaded. It's a bit kind of distorted. Well, it's not really distorted, but it just sounds a bit out of whack. It introduces some quite strange frequency combinations. So where were we? Oh, I need to disable MIDI on that other tab, because otherwise I'm going to be playing two at once. Right, back to tab 1. So the other thing I decided is, last time I was umming and ahhing about whether we're going to have 6-note polyphony or 8-note polyphony or 9-note polyphony. Decided to go with 8, although as mentioned last time, there will be a mode where if you make the sacrifice of having half the number of operators in your sound, then you get twice the number of voices, so 8/16 polyphony. Just because that's what most of the 80s keyboards had, certainly at the kind of more affordable range of the spectrum anyway. It was only really the Sega Genesis that was cut, well, and other kind of games consoles that were cut down to 6 or fewer. So a problem that arises out of this is we don't want to overload our speaker output. So I don't think, did we not have polyphony at all last time we made a video? I don't actually remember. But the question is, you don't want to overload the speaker output by playing twice as much volume. It would just crackle and be horrible. But at the same time, if you half the volume of each note, then if we're supporting a maximum of 8 notes, each note's only going to output like 1/8 of the maximum volume. It's going to be quite quiet. Especially if we go to 16-note polyphony with a fewer number of operators. Or if when you use panning as well. So I never really thought about it this way before, but at the moment, yeah, we don't have a UI for panning, but it is in the back end, so to speak, in the synth itself. And so it defaults to being panned in the center. So an output from an oscillator or an envelope that's at like 1 in terms of amplitude produces an output on the speaker at 1. But then if you pan like hard left, instead of being 1 on the left and 1 on the right, it's going to be like 2 on the left if you pan hard left. So that also has to be accounted for, so you don't overload the left speaker. Anyway, so the problem that we had is, so ideally we should just divide our output. So division is basically just like an amplifier that's not turned fully up. We should divide by twice the polyphony. Yeah. So that whatever you play, you can even play like, you know, a really big chord that uses all the voices, and you'll never overload the speakers. The trouble with that is that it goes really quite quiet if you just play like solo parts, which you might want because you might want to support like the full dynamic range. But on the other hand, it's quite annoying. Like that's just not how computer applications work. That's not how, you know, that's not how like modern music tracks work either. Recordings. So what we want is some way that we can play the solo parts and they're clearly audible, but when we play like big chords and like multiple instruments as well, because at the moment we've got all voices like set up, it's actually the same. But when we get the sequencer software written, you'll be able to like set up like different patches on different voices. So what was I saying? Yes, we want decent volume when we're soloing, but we don't want to go over the maximum when we're using our maximum kind of amount of polyphony available to us. So what we need for that is something called a compressor, a variation on that called a hard limiter in this case. Yeah, so what I've labeled pre-gain, if that's turned down to 1, then that's our divide by 16 thing. That's the maximum dynamic range, but it'll be quiet when you're just typing solo notes. I forgot we had ring modulation on. It's kind of annoying because it's a bit of a harsh sound in its raw state. Let's just go back to so I don't know about you, but I've got headphones in and it's actually a bit more clearly audible. But when you're just going through like crappy laptop speakers, it's really quiet. In fact, computers have like circuits, like hardware circuits that effectively do a similar thing to this compressor when you plug headphones in, so that you don't like you're not tempted to turn up the volume and like on like the quiet bits of a song and then like deafen yourself when the loud bits come. So depending on how you're listening, yeah, at the moment it's quite hard for me to tell the effect of changing these parameters because I've got headphones in, so that you don't get feedback. But yeah, that is what it does. Why not? When you get access to the software, when it's completed. Yep. So one, that there's no compression, there's no messing around with the volumes. It's kind of unedited, raw, but it's quiet on solo parts, at least if you're not wearing headphones. And then you can turn it up to 4, which is a lot louder for the solo parts, and you've got some compression. And then, yeah, the ratio controls. Basically, if I turn the ratio up to 20, then it means that the quiet bits can be really quite loud, and when you add extra notes, you don't add much in volume. Whereas if I turn it right down, then it's more of a gradual slope. Yeah, I did have a graph illustrating this. Compressor. Okay. Yeah, so there's the effect when the ratio is 20. and this is like number of keys held down basically. So you can see it goes like whoosh, and then it flattens off. And if we turn it down to 2, it's more like that kind of curve in terms of input volume and output volume. Yep, that's the compressor. And the release time is like how fast does like the circuit like react, because it kind of cuts in and out as you're playing. So you can experiment with that parameter as well. Yeah, so the compressor was something that I wasn't really planning on adding, but it's just a kind of necessity for like modern systems. It's not something that was, you know, these parameters were not something in a Yamaha manual. They were not things that you could edit on the synths of the past. Yes. Right. Now, just remembered what comes next. What comes next is we're going to use a feature that the UI is kind of partially implemented for, and we need to access the audio engine directly to edit something that doesn't yet have a UI. Not synth music input dot solo 1. So what I'm doing here is just switching off like all of the voices except for number 1, which is useful for what I'm about to do. So now we have the portamento function. So if I turn that up, then that's your glide. So 1 second. Yep, sorry. I just got a bit confused there. Let's turn off the LFO because I think that is confusing. It's just hard to interpret what's going on in the sound with so many features. There you go. You can hear the glide, and the higher we have this, the slower it is, the longer it takes. And then the fingered option, I don't actually remember playing with that enabled very much. I hope it works. I hope it's not just a UI waiting for an implementation. Yeah, it does do exactly what it should do. So if you play notes separately, then there's no glide. But if you hold a note down and then press another one, then it glides. It also responds to over MIDI. You could have like so in the old synths manuals it mentions a foot controller, which my keyboard actually does have a connector for that, but I don't have one. Yeah, you can just map it to like a button or something, and then that enables you to like turn on and off portamento for individual notes, even when you haven't got 2 keys held down. You can just turn it on and off arbitrarily as you feel. Yep. So yeah, there's some stuff on MIDI in the background. Yeah, I implemented some other MIDI control features. I've forgotten what I mapped these to now. Oh, yeah. So this potentiometer, this is actually mapped to the portamento duration apparently. don't know why it's mapped so short. Yeah, that's. I thought that was a problem with the software. No, that's how I've set up my MIDI control. I guess the range of that. Yeah, turning it fully clockwise and anti-clockwise. It's only actually sending out numbers in the range and automate. That's why. It will go the full range in the normal configuration. What else did I change? I think that's changing. Oh, it's still got portamento. Oh, that one's mapped to portamento as well. I thought I'd left one mapped to like feedback, but apparently not. Yeah, so that one's mapped in the conventional way. Oh yeah, something is mapped to feedback. Because it's been edited there. What one was mapped to feedback? Ah, that's this one. Yes. Maximum feedback is too much. Actually, it's not too bad because I've turned down the output level of operator 1. Yeah, if you have this at 99 as well, then it just goes to like, it's almost like white noise, but not quite. At least it normally is. I'm not sure what's going on. Oh, yeah, sorry, I'm used to hearing it in, if we switch to algorithm 1, disable the other ones. Normalize the volume to maximum. I have no idea. Oh, yeah, because we've got an envelope on it. I set that to 0 decay. Yeah, now especially if we turn off the low pass filter. Anyway, you get the picture. I'm not quite sure why it's not as like white noisy as it should be. I'm not sure what I've set somewhere else. Oh, we got tremolo. Yeah, but frequency is at 0. Ah, there we go. There's our white noise. What had happened? Yes, that's interesting. I probably need to sort that out. So the LFO had been frozen at like its maximum position, or rather, it's yeah. Yes, there you go. There's another lesson. Stopping an LFO is not the same as deleting it from the system. Yeah, so it was attenuating some of the volume, and then therefore it wasn't feeding back as much. So there's your white noise. You could use to make drums or something. or you can use less extreme versions. Turn the feedback down. There we go. That's a more sensible level. It makes it sound like a kind of a filtered, a sawtooth wave that's been through a filter compared to normal. It's a sine wave. So that's feedback, which I hadn't really intended to go on in that much depth. Except, yeah, the last thing to say about that is, so the original Sega Genesis, or in fact all of the early generations of Yamaha FM synths, they only supported a value between 0 and 7. But I just thought it would be better to make it more consistent with the rest of this modulation matrix. So you can still get like the classic values. You just need to like multiply by like 14. So 14 would be equivalent to like 1. And then 7 is equivalent to 98. And that's feedback. I should probably add a little note somewhere just to list out the multiples of 14 so you don't have to do it in your head. Yep. And the last thing is I've started working on the sequencer, which is pretty cool. So gonna have a go at that. In fact, let's switch to the other tab. Right. 1 second, I'll be right back. Hello, I'm back. I just had to take a quick break. Which of course was like 0 seconds for you. So the sequencer, I'm going to click to upload a file, and you'll see like these are spreadsheet files. We'll get to that in a minute. So this is not like the final like format of like saved sequences at all. It's just a kind of like a chicken and egg problem. Like I need to like write like the actual like meat of the sequencer, but then like how do you compose sequences like without a user interface? And vice versa, if you create the interface first, then you can't actually like play anything. So it's just buttons that don't do anything, which you can probably tell that I prefer writing the actual sound engine more than I prefer writing the interface. But yeah, so, and yeah, let's just load. Yeah. And now we haven't actually got a play button yet. So we need to go back into the code console. Play. Player. Yeah. There you go. That is the beginning of the sequencer. So that will be a kind of a continuation project. At the moment, yeah, the goal is still to release the synthesizer first and then continue on to do the sequencer. But it's just useful to be able to play, test stuff back. Yeah, like I say, loading spreadsheets is just for test purposes, really. There will be a proper format for saving stuff. But you know, I might just leave that feature in as like an extra little like Easter egg. Like, by the way, you can load spreadsheets, just in case anybody wants to do any wacky stuff that has like, I don't know, formulas in it or something. I'm just entering like numbers and like stuff in the cells. But yeah. And if we go, I don't have it loaded up. Oh, what's happened here? Right. So we're back in the 90s Amiga tool called Pro Tracker, which I've mentioned before in the previous episode. So this is our. Why is it so slow? Honestly, the 90s wasn't that. Right. Anyway, that's quite a nice little rendition of Pagabel's Canon that I just found on the internet this afternoon. But to look into it in more depth. So as I mentioned before, this works on what's called the tracker interface principle, which there's loads of variations, and I'm going to make my own, which is like better than all the ones that came before. Yeah, I've been doing a bit of composing as well in different packages, just a few bars here and there, just to get a bit of a feel of like the pros and cons of different things. So yeah, as you can see, if I play it again. Thing. So it just moves down vertically. So when it hits this line, it's like, I've got to play an A on like channel 1. So it basically is a spreadsheet in a way. It has a column that has the note, and then this one's the octave. Then these next 2 digits are like the instrument number, like the patch number. I think this digit's always 0. This one is for what's called effects, so that could be anything, like vibrato would be an obvious thing. So usually in tracker programs you have to kind of memorize like code, so it would be like, I don't know, code 8 or something for a vibrato and code 1 for an arpeggio. I think that's correct. I think an arpeggio actually is 1. I don't know what the code is for vibrato. And then the last 2 digits are like the parameters that will control like how fast and how deep the vibrato is. Yep, I'm going to change that and make it more intuitive. But yeah, we're not going to have like coded effect numbers. I mean, we do it at the moment because I can only enter stuff in using a spreadsheet, but we're going to improve on this. But we're going to keep the general principle because I quite like that. You know, you can just see everything that's going on the track at that moment in time just by looking across the columns. It's quite a nice way of working, I think. Yeah. So now I want to go to my spreadsheet. Oh, why didn't that work? Come on, Windows. So here's my implementation. So we've got a note column, and then I've added a velocity column. A lot of trackers have that, but not Pro Tracker because Pro Tracker is a bit older. Although in most trackers it just acts as like a simple volume because they're not linked to like FM synths in general. Whereas, you know, we will actually be able to like change like some of the envelope parameters and stuff, you know, make stuff velocity sensitive. Will be a true velocity column. And then effect, which is yeah, like really impenetrable code. Like I really don't expect people to like actually work in a spreadsheet. It's just for me to like, I can load up this file and play it, and I know that the basics of this, the synthesizer and sequencer are working. Like nothing's broken since the last time I tested it. In this case, yeah, I think M stands for the modulation effect. And then the first two is like effect number 2, and then the value is 2048. Which I think this is vibrato, if I recall correctly. Yeah. So yeah, it's like doing a ton of vibrato at maximum amount, and then it's doing like 0. Just putting it back to how it begins. Oops. We do not upload anything from that folder. Right, where was I looking? GitHub. Test. So there's several more sequences in here. This for release, we've already covered that. I don't know. I mean, you get the general idea. You probably don't need to see every sequence of them. So here's one with a delay column. In fact, I'm supporting negative delays. That's something that I've never seen on track of. So yeah, the tracker approach has some pros, but it has like one kind of major con, which everything has to happen like on a grid line. But you can have like each line is divided into a number of what's called ticks. By default, there's 6 of them. So within this line, there's 6 ticks, and usually the note happens like on the first tick of each line. But I've set it to have like a delay of -2, so it will happen 2 ticks before, so this note will actually play kind of in between the lines, as it were. And so this note will be shortened, and this note will be lengthened from where it would otherwise be if there was no delay column. Yeah, again, some trackers, modern ones, have dedicated delay columns. Old ones like ProTracker don't, but it was available as an effect. I think that's probably all to show, really. Well, I mean, it could go through more and more spreadsheets, but anyway. Then we could just load one of those. Let's load the basic sequence. You'll hear that it really is vibrato. Oh, except I turn the level off. I don't yet have an effect command to set. Oh no, this one has it on. Good. In fact, this is the one that has it at 55 hertz. Yeah. Maybe turn the tremolo off. It's kind of obscuring. Well, I think you did hear it. Yeah. It's moving so fast here. It is a timbre variation. There we go. That is the test case that I run, just every now and again to check they haven't broken. I think we're building up more and more test cases to test different things. That's it for this time, folks. No, there is more. There is more. But this is the end of like the practical part. So if you want to tune out now, then do. But first, don't forget to like, subscribe, comment, get the bell on for notifications so you never miss out on one of my very, very important videos. I'd be offended if you don't put bell on them. No, not really, just kidding. And now for something completely different. Well, not very different, but a little bit different. So, yeah, we already talked about panning. I thought we'd just cover a little bit of the background. Like I mentioned before about how I got interested in FM synthesizers, but I've mentioned before about like Sega Genesis versus like more premium models and all this kind of stuff. Like what models were available in like the 80s, like what models are available now in terms of like hardware synthesizers, and yeah, just a bit more background on these systems that I wouldn't say emulating exactly. Well, yeah, I suppose I am, but we're going to go beyond that and add, extra features as I've demonstrated a little bit today. We had ring modulation, and I've talked about how we're going to have 4 ring modulators in addition to four FM operators. But let's just go through I was about to say flowchart. It's not a flowchart. The chart of arrows and boxes. So it all started out in 1983, and so each one of these boxes is coded with. So the chips have like code numbers. In fact, they have 2 code numbers. They have like YM and then like some number, which is like the actual like the physical chip, and then they'll be called something like OPS or OPM, which is like the series. Kind of describes as functionality rather than the actual physical chip. Well, obviously there's some overlap. So the OPS chip was the first FM chip. So that was in the DX7, which was like the flagship product, like the first commercially successful FM synthesizer, launched in 1983. And yep, there are a few other synths based on the same chips, notably the DX9. So the OPS one has 6 operators per note. So that's in a way more and in a way fewer than what I'm doing, because it's 6 FM operators, whereas mine's 4 plus 4, 4 FM operators, 4 ring modulators. But we also have a bunch of other things that mean that, because we have more wave shapes, so that means that you need fewer operators to achieve the same kind of sound. So I had 6 operators per note, except in the DX9 where they like disabled 2 of them basically. They used the same chip, but in order to make a budget on the product, they just disabled some of the functionality. 16 voices, so that would be 16 note polyphony. 1 waveform, it could only do sine waves. And then, so following the arrow over to the right, they made a slight revision to the OPS chip in 1986. So they added like more precision, so some of the parameters could have like, I was going to say fractional values, but that's not really how it worked. But there were more values available for a parameter. And it also added stereo support. The original was mono. So there was a DX7-2, slightly less famous, basically the same, it just had stereo. with TX802, which is like a DX7, like without a, or DX7.2 rather, without a keyboard, is a sound module. So that's one direction. And the other direction was to develop the more affordable version, rather than just deactivating two voices. They eventually decided to make, a brand new chip that was specifically, had less functionality, so it was cheaper to produce. I don't know, like fewer transistors, probably, stuff like that. So that's the OPM chip, which was used in a bunch of Yamaha synthesizers, DX21, 27, 100. A sound module called the FB01. They even outsourced the tech. Outsourced? That's not the right word. Licensed the technology to Korg to use in their DS8, which is an interesting instrument actually. It's an FM synthesizer, but it masquerades as a subtractive synthesizer. So you can't use all of the algorithms, only like two of them. And it describes stuff in the manual like this is the wah slider, and it talks about like filters and stuff, and like it doesn't actually, electronically speaking, have any filters. It's just using FM, as we talked about earlier. When you use the tremolo effect on a modulator, it sounds like wah. It's the equivalent of wah on subtractive synthesizers, but it's not usually called like that. Yeah, so that they made basically like FM for dummies, basically. Like you didn't have access to all the parameters, but it was a lot more intuitive. So it was very interesting reading the manual for that product and seeing videos of people using it and stuff. Yeah, it had sliders, much as I've got on screen sliders. They had actual physical sliders. Yeah. Then there's something called the X68000, which is a Japanese computer from the late 80s. MSX is another Japanese range of computers. Arcade machines, if you remember. Yeah, there used to be these places where you could go play the latest computer games that were better than what home computers could do. Put like a coin in and it lets you play a game. They disappeared in I don't know, the early 2000s, just because home computers got so powerful. Anyway, so where were we? So yeah, the OPM chip was used in a lot of things. I put /OPP. So the OPP one is basically identical to OPM, except it's not in terms of like the physical electronics. You can't just swap one chip for another. But in terms of functionality, they're the same. So what was the difference between OPS and the DX7 and OPM? So less precision. So in terms of, for example, we've seen when I've been using my synthesizer that we've seen like the attack rates and decay rates go from like 0 to 31. I think in the DX7 they would have probably gone like 0 to 100 or something like that. So basically they were able to, if you have 0 to 31, then you can fit that into like 5 binary bits. So it needed like less memory space on the chip and stuff. It's more compact. And yeah, I've got the best of both worlds in a way, in that you can reproduce classic sounds associated with all these old computer systems and keyboards using 0 to 31, but then I allow like half steps and things like that to get extra precision. Fewer operators, we've said 4 instead of 6. Fewer algorithms, well, if you have fewer operators, then there are less ways that you can connect them. That's kind of obvious. Less polyphony, so 8 voices instead of 16. So last time we talked about setting the frequencies of the operators in either ratios like 1:1, 2:1, 3:1, or in a fixed mode where you give an operator a set value in hertz and it just sticks with that no matter where you play up and down the keyboard. So OPM doesn't have that. Fewer envelope stages, yeah. So as well as the traditional ADSR, even in op-amp and in my synth, you have the sustain rate. So the sustain phase isn't completely fixed. You can have like a second decay, as it were, which I think is a kind of a happy medium for beginners. Like it gives you that extra bit of control over your playing ADSR, but it's not as complicated as what's in the DX7, or indeed in a lot of other more modern synths. Yep. Yeah, the only difference between OPM and OPP is that OPP has stereo, though it's very basic in a lot of these chips. Like you can either send like a voice to the left channel, the right channel, or both. Like that's all you can do. Yeah, and then going down to OPN, which is so OPN2 is the chip in the Sega Genesis, part of the OPN series. So even less polyphony, reduced to 6 voices instead of 8. But I'm going to stick with 8. No fine ratios, so you could only have whole numbers. You couldn't have, 1.3 to 1 or something. Did bring back fixed mode. So in a way, yeah, OPN's interesting. It's neither better nor worse than OPN. It's just got OPM. It's just got different features. Like some were removed and different ones were added. Got fewer options for controlling the LFO. So in OPM, you can choose like square wave or triangle wave or different waveforms, whereas in OPN it's fixed as a triangle wave. But anyway, the long and short of this diagram is that, yeah, I started exploring from this point because I remember the Mega Drive. I also remember the Sound Blaster card. We'll get to that in a minute. So I started exploring from there and then kind of went backwards into learning about the Yamaha synthesizers. And yeah, in terms of implementation as well, I kind of started here and then started adding other features from here and over here. So we're going to end up with something that has like the features of all of them, basically. Yeah, we're going to end up kind of in this territory over here. But yeah, completely able to emulate OPN2. So I guess that's a good segue into talking about BZ, which was 1987. So they added more precision. They added the fixed mode, so it's going in the same kind of direction. They added a second LFO, which is interesting. Yeah, I've actually gone a step further than that. So I've got a separate LFO per voice, whereas they just had 2 for the whole thing. And the other ones we've talked about before, and only had 1 LFO. Yeah, OPZ supports different waveforms instead of just a single sine wave. It supports 8 waveforms. Also has the stereo, MISC, some miscellaneous stuff. Yeah, it has a few interesting little tricks basically that build up on the concepts. It all really started with OPM. I mean, it started with OPS, but that's kind of a different kind of parallel series in a way. And then it was cut down, and then everything branched out from OPM again. So OPL, which was in the AdLib and Sound Blaster cards for PCs. So you're probably familiar with the series, the sound of what's called OPL.2, which was the standard kind of early 90s PC sound, card sound. And it was in these various other computer systems and synthesizers. So even less precision on these. Some of the envelope parameters you only get like 4 bits. No stereo. Even fewer operators. It's only 2 operators, 1 single carrier, 1 single modulator. Or you can just have 2 carriers. But that's just 2 sine waves. More polyphony, slightly. So you get 9 voices instead of 8. Yeah, OPL is a bit of a kind of quirky, kind of sideways step. Very limited LFO. Like you can't even change the rate of it. But there are 2 of them. And unlike on OPZ, where you basically allocate, like each voice can use like LFO1 or LFO2. On OPL, like basically the tremolo and vibrato run at different frequencies, but you can't actually change the frequency of either. More waveforms, so on certain versions of OPL anyway. OPL2, which was the most popular one, had 4 waveforms. But they're different to the 8 waveforms on OPZ are completely unique to OPZ really, or certainly like the later kind of slightly kind of mid-range synth OPL. Yeah. They're the ones, I'm not sure if I demoed them last time, but they're things like you have a sine wave, but like you have the bottom of it cut off, like so it's just like it's like a little, it's like a hump, but then instead of going down into a negative hump, it just stays at 0 for a while. So it's like hump 0, hump 0. So they were things that were very easy to implement programmatically. Didn't really require any extra chip space, whereas the extra waveforms in the OPZ are designed more around synthesis and creating certain sounds, and and then there was an upgrade to OPL2. There was OPL3 in 1988, which is also on some of the later sound cards. So Sound Blaster Pro 2 and ones that came after that, like the Audigy, what was it, AWE 32 and all those kind of ones. So they put stereo in. Again, it's one of these very limited forms where it's like or left, or right, or in the middle. That's it. Added 4 operator mode. It doubled. So basically doubled the number of oscillators. That either meant that you could double the number of voices. You could have 18 voices. But there are only 2 operators each. Or I was going to say you could have 9 voices with 4 operators, but that's not true. There was a limit on the number of voices that could be put into the 4 operator mode. Yep, and added another 4 waveforms, making 8 in total. Yep. So, yeah, like I say, I'm basically supporting everything in like this part of the graph. Well, except that we'll only be able to have 16 voices maximum. But, yeah, I think that pretty much covers all the bases. Like it covers the PC sound cards, it covers the Mega Drive sound, it covers the sound of the arcades and these kind of classic mid-range Yamaha synthesizers, and these ones over here as well. But yeah, just to finish our way through the diagram. So yeah, feature phones, remember them? Like before smartphones. Um, and PDAs, oh, remember them? Like these devices that like all they did was like keep your notes and people's phone numbers and stuff, but in electronic form. It was so much cooler than like having pen and paper. Um, yeah, they completely died off when we had once we got smartphones as well. And home appliances, you know, sometimes you get like my washing machine like plays a sound when it finishes it, and not just like a beep, like an entire tune, and like there's bleepy sound. So yeah, they basically adapted OPL3 so that you could so it could be used for all these kind of applications. So this is in from the 2000s onwards. Yeah, not much more to say about that. Basically, they just carried on playing the same sort of tricks. So they increased the number of waveforms, but they're they're not particularly sophisticated ones or anything. They're just mathematically convenient ones. Uh, and yeah, going right back up to the top. So we had the DX7, the slight refinement in terms of the DX7 II, and then what happened? So we had these other ones in 83, 84, 88, 86. Sorry, 87 OPZ. Uh, but then in 89, they went back to uh, started producing a new kind of premium range synthesizer, which was the SY series, the SY 77 and SY 99. So these are an upgrade over the DX7 II, a quite a significant upgrade. So in terms of FM, they support 6 operators, which was the same as the DX7, 16 voices, that was the same. But they had 16 waveforms, and more sophisticated algorithms than the DX7. Yeah, lots of subtle refinement stuff that have been. I mean, I was tempted to put an arrow between these two actually, but I don't think there's a link in terms of actual implementation stuff being passed down, but certainly in terms of like ideas, like yeah, it's like lots of refinements. Yeah. Um, oh, what was I going to say? Yes. So as well as the 6 operators and the 16 voices, it also supports using samples as well. So you can have a sample layer and an FM layer. So it's quite a sophisticated center, at least by 90s standards. Yeah, there's talk on like podcasts and stuff like about how it's kind of underappreciated because people didn't know how to kind of use it to its maximum, which was true of the DX7 as well, actually. Like, yeah, loads of rich people brought them and then just like played like the presets that came with it and didn't explore deeper. Which, to be fair, it had a really crappy user interface with just like one slide at it and put stuff. And then building on the SY series, they had the FS1R, which is a bit of an obscure machine, but it's important in terms of telling the story. So 1998. So this has got 16 operators per voice, which is like, whoa, more than anything, like kind of past or present. But 8 of them are white noise operators, so they're not sine waves, they're not other kind of musical waveforms, they're white noise. 32 voices, 7 basic waveforms, plus, like I said, there are the 8 operators that produce noise. And it has this formant shaping stuff. So it was designed, it can kind of like replicate like human voices in a way. I mean, it sounds a bit robotic, but you can kind of make it sing. Um, yeah, it's quite complicated to program, not very understandable. I don't think it was very popular because people just didn't get it. Um, but it's yet another kind of sequence in this like sequence of refinements. Um, and basically after like the 90s, like uh, FM went out of fashion because like some memory space was getting cheaper. You could have much more high resolution like samples and stuff. So FM went out of fashion for a while. And it came back in 2016. So you got the Yamaha montage and and motif as well. Um, yeah, so they've got 8 operators. They don't have these like extra 8 noise ones, but but they have the features like what they call skirt and resonance. This was stuff that came in with the FS1R. And then we've got a couple more boxes dotted around, which I'm not really sure where they fit into the timeline. They kind of don't. But there's the Reface DX. So what they attempted to do there was to like basically be so you could buy like a new version uh, rather than like bidding on like these old devices, which yeah, the thing about old electronics, they can break down. They have the capacitors in them have a kind of finite lifespan before they like burst open and leak nasty chemicals onto the circuit board and damage it. So what you have to do is like, yeah, basically desolder all the capacitors and fit new ones, which, yeah, if you're not experienced with like soldering, it's a bit of a, for somebody that just wants to buy something, like, and of course, like Yamaha's a commercial company, of course they want to sell more stuff. So, um, yeah, so yeah, they saw an opportunity. They launched the premium kind of motif and montage stuff for the kind of higher end of the market, and then the the, the retro kind of um, entry level stuff is the Reface DX, which is kind of a direct re-implementation of some of this earlier stuff. Um, yep, not much to say about that. Oh well, it focuses on one waveform, so yeah, it's pretty similar. Um, Pretty similar to this kind of early stuff before we branched out into these other boxes down here. And then there's Yamaha also make electric organs. Um, so the YC61, 73, and 88 organs. Basically, like internally, like they've always worked on like FM, but they released a firmware update this year that enables you to have direct access to some of those parameters. They're not as programmable as any of the dedicated FM synths, but it's quite a nice interface because it has it on sliders to control the ratio. Um, Sorry, to control the modulation amounts. Um, so yeah, I think it's probably got a nicer kind of easygoing feel to it to manipulate it a bit more of a hands-on way. Um, yeah, and of course, yeah, it's an organ with its own kind of bunch of organ-specific features. Like they have like what's called a Leslie speaker cabinet emulation and stuff like that. So yeah, that is the complete catalogue of Yamaha's FM synthesizers and all the various manuals I've read for looking at all the different features and different ones. Manuals for products, manuals for the chips themselves, various blog posts and stuff like that where people have talked about like reverse engineering it, figuring out how they work, and yeah, put in quite a lot of research as well as the coding to get like, yeah, get it sounding safe. And then, yes, so the FM concept was invented by a guy called John Chowning at Stansted University, and yeah, together with basically they patented it and gave like Yamaha an exclusive license to use the patent, which is why like all of the FM synths of like the 80s come from Yamaha. Well, apart from the Korg DS7, where the Yamaha licensed it on. Yeah, all of these computers and things that they contain Yamaha chips. Like it wasn't, yeah, it wasn't chips that Adlib made or anything. But that patent has lapsed now, so people can make their own thing. Yeah, I thought I'd just put in a couple of, I was going to say honourable mentions, but they're not really. You know, they're full-on implementations. But stuff by other manufacturers, the notable outstanding ones in terms of hardware are the Electron Digitone and the Korg Op6. And that is that. And like I say, I shall plug on with the synthesizer. And yeah, I think it's been very fun getting stuck into making the sequencer as well. And I think it'd just be awesome when the two come together for a complete like kind of 80s DAW in quotes. Yeah, and yeah, like I mentioned last time, I think that's really where like the beauty of it comes in terms of how you could when these chips were used in like computer systems and the interaction between like the system's main CPU and the sound chip itself, and you know, manipulating parameters faster than like a human player can twiddle knobs and things, and multi-timbral stuff, you know, putting different things on each different voices rather than just, you know, pure polyphony, you know, doing layers and stuff. Yeah, that is all for now. Catch you in the next one.